Hello friends, welcome back to C-Level Physics. Myself Srinivas, known to be BS Rao. In this lecture, I would like to demonstrate some numericals based on average speed and average velocity. Before that, we need to discuss one point, that is the relation between distance and displacement. The relation between distance and displacement. What is the distance? When a particle is under motion, the total length of the path is known as distance. Okay, the shortest distance between initial and final position is known as displacement. So now what is the relation between these two? Means distance either greater or equal to displacement. Why? Because in case of straight line motion, without any change in direction, then in that case distance becomes equal to displacement, right? In all other cases, distance is greater than displacement. Okay, so therefore on clubbing both, we can get a distance either greater or equal to displacement, right? Suppose a distance divided by time, distance upon time, either greater or equal to displacement upon time, right? Simply I divide the expression with time on both sides. So distance by time, nothing but average speed. Here displacement by time, nothing but average velocity. Therefore average speed either greater or equal to average velocity, right? And taking average velocity to LHS, then average speed upon average velocity either greater or equal to 1. So this is the ultimate result. What is that result? Average speed divided by average velocity either greater or equal to 1. Right. So now coming to numericals. Let us see. Suppose one particle moves as follows. One particle moves as follows, right? What is the displacement covered by the particle? See here, S equal to T cube minus 3T square. Okay, S equal to T cube minus 3T square. This is what displacement covered by the particle. Displacement, right? If S equal to T cube minus 3T square is the displacement covered by a particle, find velocity. Number 1, velocity at t equal to 1 second. Number 2, velocity at t equal to 3 second. Number 3, velocity, average velocity from t equal to 1 second to t equal to 3 seconds. Also find number 4, find the time at which particle comes to rest. Right? This is the given question. See here, we have expression for displacement, that is a t cube minus 3t square displacement. Alright. Now, how to get velocity by using this expression means, as you know, the differentiation of displacement or position with respect to time itself velocity. So v equal to ds by dt means the differentiation of position or displacement with respect to time is known as instantaneous velocity. That is the expression for velocity. Therefore ds by dt, that equal to d by dt of s. D by dt of s means t cube minus 3t square. T cube minus 3t square, right? Differentiation, that is v equal to d by dt of t cube minus 3 into d by dt of t square. Here 3 is constant, so I kept 3 outside. So 3 of d by dt of t square. What is the solution for this one? Means we know that d by dx of x power n equal to n into x power n minus 1. So making use of this result, one can solve this expression. Therefore, V equal to d by dt of t cube. Here d by dx of x power n means n into x power n minus 1. So instead of x here we have t. Instead of n we have 3. So replace here. That is n into x power n minus 1. What is n here? 3. So therefore 3 into x power x means t. T power n minus 1. N means 3. So 3 minus 1. Minus 3 into d by dt of t square. So here n into x power n minus 1. N means 2. Or d by dt of 3 into d by dt of t square. So d by dx of x power n means n into x power n minus 1. So here n means 2. 2 into x power x means t. N minus 1. N means 2. 2 minus 1. So this is the solution. Therefore V equal to 3 t square. 3 minus 1 means square. That is 3t square minus here 3 2 is 6 into t. 6 into t. Right. This is the expression for velocity. Instantaneous velocity. Now substitute velocity. We need to find velocity at t equal to 1 second. So number 1. See, 1 implies this is what 1. So first question, velocity at t equal to 1 second. So V at t equal to 1 second. At t equal to 1 second. That equal to substitute here. V means 3t square. 3 into t square. T square means 1 square. Minus 6 into t. T means 1. That is 3 minus 6. That is minus 3 meter per second. Minus 3 meter per second means negative direction. It moves. If velocity is negative, particle moves towards negative x-axis as an example. Now coming to second question, that is number 2. Number 2. Velocity at t equal to 3 seconds. So V at t equal to 3 seconds equal to, substitute here, 3 into t square. T means here 3. So that is 3 square minus 6 into 3. That is 3 3 is 9. 9 into 3. 27 minus 3 into 6. 18. So 27 minus 18. That is 9. 9 meter per second. 9 meter per second. Am I right? Now coming to third question. Find average velocity from t equal to 1 second to t equal to 3 seconds. What is the definition of average velocity? The total displacement upon total time taken to cover that displacement. Am I right? So coming to third question. Average velocity means displacement covered from 1 second to 3 seconds. First second to 3 seconds. Divided by 3 minus 1. That is 2 seconds. Am I right? So before that we need to find displacement covered in 1 second. S of 1. S of 1 means S of, what is the expression for S? That is a t cube minus 3t square. Now S of 1. 1 means 1 second. Substitute t with 1. That is S of 1 equal to 1 cube minus 3 into 1 square. That is 1 minus 3. That is minus 2 meter. Am I right? Now coming to S of 3. Displacement covered in 3 seconds. This is what minus 2 meter means, displacement covered in first 1 second. Now what is the displacement covered in first 3 seconds? That is S of 3 equal to, substitute, that is S of 3 equal to 3 cube minus 3 into t square. T means what? 3. So 3 square. Right? So replaced t with 3 only. That is, once again, 3 cube means 3 into 3 into 3. 3 3 is 9. 9 3 is 27. Minus 3 square means 9. 9 into 3. 27. That is 0. That is 0 meters. 0 meters. Am I right? Now, what is the average velocity from t equal 1 second to 3 t equal to 3 seconds, that is average velocity equal to delta s by delta t. The total displacement upon total time taken. Am I right? That is delta s means s of 3 minus s of 1. That is s of 3 minus s of 1 divided by delta t means what is the interval here? First to second to third second means what is the interval? 3 minus 1. That is delta t means 3 minus 1. 3 minus 1. So therefore average velocity equal to s of 3 0 minus s of 1 means minus 2 divided by 3 minus 1. 3 minus 1 means 2. That is minus some minus plus 0 plus 2 by 2. That is 2 by 2 1. So 1 meter per second. 1 meter per second. Am I right? So here s equal to tq minus 3d square expressed in terms of meters as an example. Meters. Am I right? So here velocity equal average velocity from first second to third second, that equal to 1 meter per second. Am I right? Now coming to fourth question. What is that question? Find the time at which particle comes to rest. Find the time at which particle comes to rest means where is the expression for velocity? Somewhere here. This is the expression for velocity. If particle comes to rest, velocity must be 0. Particle comes to rest, what is the velocity? That is 0. Therefore, coming to fourth point. What is the expression for velocity? Number 4. V equal to 3t square. 3t square minus 6t. 6 times t. Right? If particle is at rest, if particle is at rest, now what about velocity? 0. So V equal to 3t square minus 6t, that equals 0. Am I right? That is 3t kept common, 3t of t minus 2 equal to 0. 3t of, see, 3t is kept common, that is 3t into t, 3t square minus 2 into 3t, that is 6t. Now 3 is not equal to 0, definitely t into t of t minus 2 must be 0. So t, either t equal to 0 or t minus 2 equal to 0. Am I right? So t equal to 0, otherwise t equal t minus 2 0 in the sense t equal to 2 seconds. So this is the final answer, seconds. So initially, when will the particle comes to rest means when t equal to 0 means initially particle is at rest. So at t equal to 0, otherwise at t equal to 2 seconds. Okay. At the end of second also 1 second particle comes to rest. That is the question. Am I right? Coming to one more numerical, that is suppose for a particle moves in xy plane, for a particle moves in xy plane, okay, coordinates, position coordinates are as follows. Am I right? That is x equal to k sin omega t, y equal to k of 1 minus cos omega t. Right? Here we have two position coordinates for a particle which is under motion in xy plane. Am I right? Now, where k and omega are constants. Right? Now find the distance traversed in time t. Find the distance traversed by the particle in time t. That is the given question. Alright. Now, how to solve this sum? How to solve? Here we have one particle which is under motion in xy plane such that x equals so and so, y equals so and so. X, y are position coordinates. And differentiating both x and y with respect to time, we can have instantaneous velocities. That is dx by dt equal vx. Velocity at that is along x-axis. dy by dt is velocity along y-axis. So that's how we can get velocities along x and y-axis. Right? Now see, x equal to k sin omega t. Here k and omega positive constants from data. Now, how to get Vx here? Vx equal to dx by dt. That is d by dt of k sin omega. Am I right? That is Vx equal to k is constant from data. So kept out, keep that k outside. That is k is kept outside. K of d by dt of sin omega. Am I right? That is k into d by dt of sin x, that is cos x. See, omega t, take omega t as x, that is d by dt of sin omega t means cos omega t. Cos omega t. Once again, see here, omega t is there. So, take one more time derivative, that is d by dt of omega t. Once again, that is k into cos omega t into d by dt of omega t means omega once again constant, that is omega is kept outside, again d by dt of t. So d by dt of t means dt by dt cancel, we left with 1, that is k into omega, k omega cos omega, cos omega. This is what Vx, right? This is what Vx means x component of velocity, right? Now coming to y component of velocity. How to get y component in the same way? On differentiating y coordinate with respect to time, you can have y coordinate of velocity. That is, see, y equal to, what is the expression, k of 1 minus cos omega t. Am I right? K of 1 minus cos omega t. On extending y equal to k minus k cos omega t. Now on differentiating y, position coordinate y with respect to time, we can have Vy, that is Vy becomes dy by dt, right? That is d by dt of k minus k cos omega t, k cos omega t. That is Vy equal to d by dt of k, on extending d by dt of k, on distributing d by dt of k minus k is constant, that is k of d by dt of cos omega t. Cos omega t. Am I right? Cos omega. D by dt of k. K is constant from data. See here, k and omega are constants. So d by dt of k means 0. There is no change in k with respect to time. So 0 minus k into d by dt of cos omega t. D by dx of cos x means minus sin x. In the same way, d by dt of cos omega t means minus sin omega. Again, d by dt of omega t. One more time, d by dt of omega. Right? That is minus sum minus plus k sin omega t into d by dt of omega t is there here. Again, omega is constant. Keep outside omega into d by dt of t. So d by dt of t means 1. That is k omega sin omega. K omega sin omega. So k, this is what Vy. So we have expressions for Vx and Vy. Right? So Vx is so and so, Vy is so and so. As particle is in the xy plane, we have two components for velocity. So in vector notation, v bar can be written as vx into I cap plus vy into j cap. So in vector notation, v bar equal to vx into I plus vy into j. That is vx means k omega cos omega t into I cap plus vy into j cap. Vy means k omega sin omega t into j cap. Right? So here x component k omega cos omega t, y component k omega sin omega t. Right? Now, how do you get the magnitude of velocity root over x component square plus y component square by definition? That is mod v bar means v that is equal to root over x square plus y square. X means this one, y means this one. It is k omega cos omega t whole square plus k omega sin omega t whole square. Am I right? Whole square. That is k omega whole square is common. That is k square omega square. K omega whole square under root means k omega. We left with the root over cos square omega t plus sin square omega t on squaring. So cos square omega t plus sin square omega t. What about cos square omega t plus sin square omega t? 1. That is root 1 means 1. So final answer is k omega. So this is the expression for magnitude of velocity. These are components of velocity, x component, y component, but this is magnitude of total velocity. Now, ultimate question is find the distance traversed in time t seconds, right? So we have ultimate net velocity in magnitude. Now, from which we can find total distance traversed in time t means distance equals speed into time. So distance s equal to speed into time. That is, what is speed? K omega into time. That is k omega into t. This is the distance traversed by the particle in time t seconds. Am I right? Okay. Shall I move to next sum? Okay. Now coming to one more sum, that is here this time a particle is moving along on circle as an example, such that its radius vector changes with the time as follows. Right? If radius vector changes as follows for a particle, for a moving particle. See, if radius vector changes as follows for a moving particle, right? What is that expression r bar? R bar equal to radius vector r bar equal to b bar t of 1 minus alpha t. B bar t of 1 minus alpha t. Here b bar and alpha, b bar is positive vector where b bar is positive vector, any positive vector, and alpha is positive factor. Alpha is positive factor. Now find the time interval. Find the time interval in which particle returns to initial point, right? Find the time interval in which particle returns to its initial point. Okay, here particle is r bar equal to b bar t of 1 minus alpha t, where b bar is positive vector, alpha is positive factor. This is the data, Am I right? So r bar equal b bar t of 1 minus alpha t. Right? Here, when t equal to 0, what about r bar? Must be 0. See here, b bar t of 1 minus alpha t. If I substitute t equal to 0 somewhere here, definitely r bar equal to 0 into something, that is 0. R bar equal to 0. So when t equal to 0 means, initial point, that is initial position, initial radius vector. At t equal to 0, r bar must be equal to 0. So r bar means b bar t of 1 minus alpha equal to 0. That is, b bar never be 0. Why? Because b bar is one non-zero positive vector. So definitely t of 1 minus alpha t into 1 minus alpha t must be equal to either t equal to 0 or 1 minus alpha t equal to 0. Right? Either t equal to 0 seconds, otherwise 1 minus alpha t, 0 in the sense 1 equal to alpha t. That is t equal to 0 seconds, otherwise t equal to 1 by alpha second. Right? Here say particle returns to its initial point when t equal to 0 seconds, otherwise t equal to 1 by alpha second. Right? Here we have two instants at which particle returns to its initial point, means from the starting itself it is at its initial position. Once again it comes to initial position when time t equal 1 by alpha second. Now what is that interval here to have the particle at its initial point, means delta t equal to t2 minus t1. That is t2 minus t1. That is 1 by alpha minus 0. That is 1 by alpha second. Am I right? 1 by alpha second. Okay. Now coming to one more numerical, that is one more numerical. Suppose this time we have expression for velocity. If v equal to 3t square plus 2. If v equal to 3t square plus 2, right? Meter per second. Find displacement covered from t equal to 1 second to t equal to 2 seconds. Right? This time you are given expression for velocity so and so. Find displacement covered from t equal to 1 second to t equal to 2 seconds. What is meant by velocity means the rate of change of position with respect to time, that is ds by dt. So ds by dt equal to v. From which ds equal to v dt. ds equal to v times dt. Within a time interval of dt, that is within an instant dt, what is the displacement covered? ds. Suppose this is what ds in an instant dt. So in a small instant dt, what is the displacement covered? ds. In a time interval t1 to t2, what is the displacement covered? Means displacement covered, we can write like this. See, this is also ds, this is also ds, but here this is in time dt, this is also in time dt, this is also in time dt, this is also in time dt. So in a time interval of t2 minus t1, we have so many instants like that. In every instant, it is covering a small displacement ds like that. And adding all these ds values, we can have large displacement. Am I right? That is, how to get this large displacement from here to there, that is s. From here to there, that is s. How to get this large displacement? S means by adding ds plus ds. Okay, mathematically that can be done by one mathematical tool, that is what? Integration. Integration in the sense summation of all small elements. That is integral ds equal to integral v dt. Integral ds equal to integral v dt. Am I right? Integral v dt. Okay. What is the meaning of integration? Summation. If it is 1 ds, okay, that ds itself, but on integration, by taking integration somewhere here, that means to say that we are adding all ds values in an interval from t1 to t2. So definitely it gives log displacement. What is the interval here? T1 to T2, that is 1 to 2 seconds. That is T1 to T2 means 1 to T1 means 1, T2 means 2 seconds. Right. What is the displacement at T1? S1. At at T2, that is S2. Okay. At time T1, S1 is the displacement. At time T2, S2 is the displacement. At S2 is the displacement. Right. That is integral ds means delta s. Limits S1 to S2. Here T1. Here T1 lower limit, T2 upper limit in case of time. In case of displacement, S1 is the lower limit, S2 is the upper limit. S1 is displacement or position at T1. S2 is the displacement or position at T2. Am I right? Similarly, integral v dt. V means what? 3t square. 3t square plus 2 into t2. What are the limits for time? Here t1 means 1 second, t2 means 2 seconds. Here 1 second, here 2 seconds. Right? Integral delta s means replace delta s by writing s2 and s1 successively. That is delta s means s2 minus s1. S2 minus s1. Upper limit minus lower limit. That is 3 into integral distribute integration for all steps here, all terms here, 3 into integral t square into dt plus 2 into integral dt. What are the limits here? Limit lower limit 1, upper limit 2. Here also lower limit 1, upper limit 2. So on extending, you can have like this. See, on extending, we can have like this. So S2 minus S1 equal to 3 into, how to get integral t square dt means we have one relation. What is that relation? Integral, we know that integral x power n dx equal to x power n plus 1 by n plus 1. This is the relation. X power n plus 1 by n plus 1. So instead of x, we have t here. Instead of n, we have 2 here in the first term. That is S2 minus S1 equal to, now say here 3 is there. Integral t square dt means t power, x means here t power n plus 1. N plus 1. Power n plus 1. So n means here 2. That is 2 plus 1 by 2 plus 1. Alright. Keep in box. Now write lower and upper limits 1 to 2. So first term is over. Coming to second term, that is plus 2 into integral dt means t1. Limits 1 to 2. Now replace t by writing upper limit one time and lower limit one more time. That is S2 minus S1 equal to 3 by 3. 2 plus 1 means 3. 3 cancel. So we left with nothing here. 1 here, that is 1 into t power 2 plus 1 means t cube. Limits 1 to 2 plus 2 into t, limits 1 to 2. That is S2 minus S1 equal to. Now replace t by writing upper limit first. That is t cube means 2 cube. 2 cube minus, this time replace t by writing lower limit. That is 1 cube. Plus 2 into replace t by writing upper limit 2 minus, once again replace t by writing lower limit 1. That is S2 minus S1 equal 2 cube means 8. 8 minus 1 plus 2 into 2 minus 1. 8 minus 1, that is 7. 7 plus 2, 9. So S2 minus S1 equal to 9 meter. 9 meter. So this is what displacement covered from t equal to 1 to t equal to 2 seconds for a particle which moves with a velocity v equal to 3d square plus 2. Right. Now coming to another sum, that is coming to another sum. This time particle moves along positive x-axis, with a speed v equal to a particle moves along x-axis with a speed v equal b root x. Am I right? V equal b root x. Find its speed. At t equal to tau. What is the condition? Assume particle is at origin. Assume that particle is at origin at t equal to 0 seconds. At t equal to 0 means initially when our observation starts. So at t equal to 0, what is the position of particle is at origin? Is at origin means there is no position coordinate for particle, that is x equal to, at t equal to 0, x equal to 0, that is the condition. Now here we have v equal to b root x. From data given that v equal to b root x. V means what? Dx by dt. So dx by dt, differentiation of x with respect to time, equal to b root x. Now take this root x to this side, that is dx by root x equal to b dt. Dx by root x equal to b dt means, what does it represent? Means within an instant dt, the displacement covered is dx. Okay, what is saying is, that is in an instant dt, dx is the displacement covered by the particle. Now in an interval from t1 to t2, definitely particle moves through a large displacement. This is the displacement, dx is the displacement within small instant. Okay, if you observe within a time interval, large time interval, definitely it moves through large displacement, right? So how to get that total displacement in an interval means by adding, that is by summing in the sense by integration mathematically. So integral dx by root x equal to b into integral dt. Here b is constant from data. So integral dx by root x equal to b of integral dt. Now what are the limits here? Initial instant t equal to 0. So limits 0 second to t. Here 0 at 0 second, what is the position? 0. At t seconds, what is the position? Let it be x. Right? Let it be x. Now coming to solution. Now integral dx by root x means integral 1 by root x in the sense x power of 1 by x power of means x power minus of into dx. Limits 0 to x equal to b into integral dt, limit 0 to t. That is, we know that x power n dx equal to integral x power n dx equal to x power n plus 1 by n plus 1. Right? X power n plus 1 by n plus 1. Now making use of this result, now we can have x power, what is n here? Minus of. N means here minus of plus 1 by minus of plus 1. Limits 0 to x. B into integral dt means t1. Limits 0 to. Now minus of plus 1 means of. 1 by of means 2. 2 into x power minus of plus 1 means x power of, that is root x. 2 root x. 2 is kept outside. Limit 0 to x. B into t, 0 to t. Now this time I am substituting upper and lower limits. So 2 into root x. In case of x, here once again x only. So 2 into root x. upper limit is substituted. Now minus this time lower limit, that is root to 0. B into upper limit t only, t means t only, t minus what is the lower limit in case of t? 0. That is 2 root x equal to bt. 2 root x equal to bt. That is implies root x equal to bt by 2. bt by 2. On squaring x equal root x whole square means x. X equal to bt by 2 whole square means b square t square by 4. Now we have expression for position with respect to time. That is, this is the variation position of particle with respect to time. On differentiating x with respect to time, we can have speed. That is dx by dt equal to b square by 4 is common. Now d by dt of t square. d by dt of t square. Okay, dx by dt on differentiating both sides, dx by dt equal to b square by 4 of d by dt of t square. That is dx by dt means v equal to b square by 4 into d by dt of t square means 2t. Why? Because we have in d by dx of x power n equal to n into x power n minus 1. Okay, since d by dx of x power n differentiation equal n into x power n minus. In case again we have 2 only. So d by dt of t square means x power n means here 2 square, t square, n into, what is the solution? N into means 2 into x means here t only, 2t whole power n minus 1, that is 2 minus 1. 2t, 2 into t power 2 minus 1 means 2 into tt1. 2 into tt1. Okay, that is b square t by 2. 2 by 4 means 1 by 2. So b square t by 2. So this is what expression for speed. Now replace t by writing tau. Why? Because the question is to find speed of particle at time t equal tau. T equal tau means replace t by writing tau. That is implies b square tau by 2. This is the ultimate answer. Okay friends. Signing off for today. Once again requesting all the audience to please subscribe C-level physics, which is very useful to foundation NEET IIT aspirants. Thank you.